In processing, every color you make can have a certain amount of transparency associated with it. Now, this is a really interesting idea because it means transparency is not based on the objects that you're drawing. Transparency is associated with the colors that you create. No matter what you use those colors for, they can have transparency on them. Let's take a look at this in action. Here's a little sketch I wrote to demonstrate transparency. We have just a gray background with a single horizontal dark gray rectangle in the middle, and neither of those things are going to change. What is going to change is a rectangle that I draw on top of this, and I'm going to control the colors of that rectangle with the mouse. Let me first show you what the rectangle looks like. It's a brown fill with a thick yellow stroke, and I'm drawing that on top of the dark gray rectangle. I'm going to move my mouse down to the bottom left corner, and I'll show you what happens as I change the transparency of the two colors that make up that rectangle, the stroke color and the fill color. So as I move my mouse to the right, I'm changing the opacity or transparency of the stroke color. And you can see it's becoming more and more visible as I move my mouse to the right. I'll stop about 2/3 of the way, and you can see we can still see some of that dark gray rectangle coming through this partly transparent stroke. But I'll make the stroke more and more opaque until finally when I reach the right-hand side, the stroke is fully opaque. So I'll move my mouse back to the left and you can see the stroke fade out. And now I'm going to do the same thing with the fill color, but I'm going to control that by moving my mouse upwards. So the higher up I go, the more opaque the fill becomes. And I'll stop about 2/3 of the way through, and you can see that we can still see some of that gray rectangle coming through. But as I push the mouse higher and higher up, now we have a fully opaque fill. And I'll pull the mouse back down so you can see the fill becoming more and more transparent. And now I'm going to move my mouse around inside the window, controlling the transparency of the stroke and the fill independently. And you can see I can make a very opaque stroke with a transparent fill, or I can make a very slightly transparent stroke with an opaque fill. And you'll notice also that there seems to be a third band in the middle. The very thick stroke is drawn by drawing half of the stroke outside of the filled area of the rectangle and half the stroke inside. So that thick stroke is centered on the rectangle itself. So if I make the stroke fully transparent, we see there's the rectangle. And when we draw a very fat stroke, it's centered on the rectangle. Now, when the stroke is fully opaque, well, it covers up that little bit that it's overlapping. But when the stroke is slightly transparent, we can see the fill color peeking through. And we can make the fill partly transparent. And I can just sort of move my mouse around and control the opacity or transparency of the fill and the stroke independently. So every color, whether you're using it for filling or stroking or any other purpose, can have some transparency associated with it, all the way from fully transparent to fully opaque and everywhere in between. So let's see this in a little more detail. You've probably noticed that each time I mention transparency, sometimes I also talk about opacity. They're pretty much the same idea. If something is very transparent, then it's not very opaque. And if it's very opaque, it's not very transparent. In fact, it might be better to think of processing's control over colors as control over opacity, because we're going to use a number to describe how transparent or opaque something is. And as that number goes up from 0 to 255, the color we're controlling goes from transparent to opaque. So if we assign a color an opacity of 0, here I'm assigning it to the fill color of this rectangle, then the color is fully transparent. It has no opacity. As I start giving it larger and larger values of opacity, it becomes more and more opaque. And we see less and less of what's behind until finally when we reach the value 255, which is the maximum value, just as it's the maximum value for red, green, and blue, then we have a fully opaque color. So just like red, green, blue go from 0 to 255, so too does opacity. 0 means transparent, and 255 means opaque. Sometimes the transparency value is referred to as alpha. This is the Greek letter alpha. And this is because in the original paper, the computer graphics research paper that introduced this method for controlling transparency, the author used the Greek letter alpha to represent the amount of transparency. And it stuck because it's a lot shorter than transparency, and it's even a little shorter than opacity. So he chose the Greek letter alpha because it was convenient, and it stuck. So you hear people talk about the alpha of a color. And when they say alpha, they mean exactly the same thing as opacity. So how do you define opacity in processing? No problem. To create a color in processing, we only have to call color. And within parentheses, we give it, if we're in the red, green, blue system, R, G, and B values. And if we're in the red, green, blue system, we give it red, green, and blue values that are separated by commas. And each of these is a number from 0 to 255. To create a color that has some opacity associated with it, you just give it a fourth number, which I'm writing A for alpha. You don't create the color and then describe how transparent it is. The transparency or opacity is part of the color itself. If you don't give a value of A, if you just give RGB, A is assumed to have the value 255, meaning fully opaque. So you don't have to give it an alpha value if you don't want. But if you do, you can give it a value from 0 to 255. You can do the same thing if you're using the HSB system. Instead of giving it 3 values between 0 and 255 for hue, saturation, and brightness, you give it 4 values between 0 and 255. And the last one is alpha. Finally, if you define a color using the shortcut where you give it just a single value meant to create a gray color because that single number is used for both red, green, and blue, well, you can also give it another value, another number from 0 to 255. Now, we've seen that we can extract the color components from a color using red, green, and blue, and of course we can get back the alpha as well. So here's a color variable I'm creating. I'm calling it CLR, just for convenience, CLR, and I've given it some very recognizable values, 100, 150, 200, 250. If we want to get the red value, we just call red on CLR. The green value and the blue value are the same. We call red, green, and blue, or we call alpha. And that will give you back the value of alpha for this particular color. And of course, you can also call hue, saturation, and value. So let's see this in action. So here again, we have a little sketch that has a gray background. I've got a dark colored rectangle and an ellipse on top of it. And again, I'm going to control things with my mouse. As I move my mouse to the right, I'm going to change the fill color on that ellipse, which is sitting in front of the rectangle. All the way to the right, it's fully opaque. Off to the left, it's transparent. I'm not affecting the stroke color. I've also got another ellipse in there, and as I move the mouse up, that ellipse appears, and it has a stroke and fill that are both being changed in opacity by the mouse. And so I'm stroking and filling this, but both of those colors are dependent on where the mouse is located. And of course, as before, we can move the mouse around anywhere inside and change the amount of opacity between these two guys. So now you have another design tool under your belt. Processing lets you attach a transparency value to any color, and that transparency then shows up no matter what you draw using that color.